Hey, my name is Raj Patel, and I'll be doing problem 22 in section 1.7. The problem statement is, suppose that at time t equals 0, half of a logistic population of 100,000 persons have heard a certain rumor, and that the number of those who have heard it is increasing at a rate of 1,000 persons per day. How long will it take for this rumor to spread to 80% of the population? Okay, so basically these right here are your givens. So P of T is going to represent the population that has heard the rumor. P initial, or P at time 0, is 50,000 because it says half of the logistic population of 100,000 persons have already heard the rumor. So that would be 50,000 people. And then P prime 0, which is the rate dP dt, is equal to 1,000 because the problem statement says it is increasing, the number of people that have heard the rumor is increasing at a rate of 1,000 persons per day. So that's going to be that. And then what we're trying to find is the time at which 80% of the population would have heard the rumor. Okay, so P of T equals 80,000. We're trying to find T. So the first step is, this is the equation for logistic growth. It's dP dt equals K, P, and then M minus P. M is going to represent the total population, so M equals 100,000 persons. The hint in the problem statement said to find K, so that's what we're going to do first. We're going to plug in all of our values that we know and solve for K. Okay, so we know dP dt, or P prime, is equal to 1,000, and then K, and then we know P is 50,000. P prime, right? 50,000 is how many people initially heard the rumor. And then 100,000 total population minus 50,000, which is, again, the population that has already heard the rumor. After solving for this, you get 1,000 equals K times 2.5 billion. And solving for this, you're going to get K equals 4 times 10 to the negative 7th. Okay, the next step is actually going on and finding T for 80,000. So this equation comes directly from the book. Basically, this is another step you could have done on your own. You could have just plugged in your values into here and then split the variables on different sides and integrated to get this equation right here. But since this was already given to us in the book, I decided to just copy it down. This equation is on page 77. It is equation 7. Okay, so plugging everything into this, we're going to solve for T. So we get 80,000, which is the population that we're looking for, the T at 80,000. Okay, so 80,000 equals M, which is total population, 100,000, times initial population that has heard the rumor, 50,000. And down here is the same thing, 50,000 plus M total population minus initial population that has heard the rumors, 50,000, e to the negative K, which is what we just solved for. M is the total population, and T. So we're just going to simplify this a little bit. We get 80,000 equals 5 billion over 50,000 plus 50,000 times e to the negative T divided by 25. I'm going to divide this, or after multiplying 80,000 by the denominator, I get 5 billion equals 4 billion plus 4 billion e to the negative T divided by 25. I'm going to divide this whole thing by 1 billion. Just to simplify things, will make it a lot easier when it comes to plugging in the calculator and whatnot. Okay, and then we'll be going to the back. Okay, so this right here is just me kind of just simplifying things and solving. And basically, what I do is after I divide everything by a billion, I get 5 equals 4 plus 4 e to the negative T divided by 25, and I get 1/4. I'm going to divide the 4 over. That's how I get the 1/4, and I get 1/4 equals e to the negative T divided by 25. So same thing as 0.25 equals e to the negative T divided by 25. E raised to the power is what I mean. And I'm going to take the natural log of both sides, so I could get the exponent, or the power down, the power of e. I get ln of 0.25 equals negative t divided by 25. So that would be negative t equals 25 times ln of 0.25, just moving down and simplifying things. And you're going to get the negative on the other side, so you get t equals negative 25 times ln of 25, or 0.25, sorry. And just plug that into your calculator. You're going to get t equals 34.657, and rounding that, you get t equals 34.7 days. So it would take 34.7 days for the total population, for 80% of the total population to have heard the rumor. And keep in mind that it's starting already with 50,000 people, or 50% already know the rumor. And that is it.